I love C. It's simple, easy to learn, and directly tied to the best family of operating systems. But there is something I absolutely hate about C. C compilers, with GCC alone having more than 22 million lines of code, all for a language with 32 keywords. So I decided to create my own C compiler. But how do compilers work in the first place? So the first stage of a compiler is the lexer, where we take the source code as a string and we parse the string as a series of tokens so that our computer can understand better the source code. I documented the making of this project in live, so let's start with some programming. Now I'm able to parse simple mathematical expressions. I structured the lexer so that it returns me a linked list of tokens that can then be iterated to process all the source code. Now to the next part, the abstract syntax tree. The AST is a data structure used to represent all the statements and expressions of the program. I decided to generate it using a recursive Dashent parser, which is a type of parser that implements operator precedence by starting to check for expressions with the least precedence and then recursively trying to find expressions with the most precedence. Now let's jump to the code. I need to expose this, so parser.h. Okay. So what now? Of course, parser.c include stdio.h. There was another error. Oh yes. Yeah, okay. Very good. So now I can build trees representing arithmetic expressions. But before continuing on more complex stuff, I realized my code was a mess and I had to do some optimization. Since branching is slow already and compare strings is even slower, I decided to implement some kind of map to get numbers from strings. But since hash maps are difficult to implement and memory inefficient, after I realized all the strings I was trying to compare were just a few characters long, I decided to use a trie data structure. A trie is a kind of tree which has single letters in each node branching to other letters, so that traversing a tree using the string's characters as indices will get a leaf containing the value mapped to a specific string. Much better now. The last thing I have to do is code generation. This is the part where the compiler finally translates the AST to machine code. In my case, I will be generating assembly to a file and then use the assembler to output an executable. And finally, I can compile simple C code like this. Here I'm calling the write function, which is a Unix system call, to print the usual hello world message. I'm not using printf because that's a function with variable arguments and I haven't implemented those yet, but as you can see, it works. And that's all for today. I hope you enjoyed the video, and if you did, consider subscribing to the channel for more content. Remember also to follow me on Twitch if you want a more in-depth explanation of what I do in these videos.